Hello, Clayton Balmas here. I'm your teacher with our video classroom with SynMax University here at synmaxperformancelubricants.com. Now, we're talking to you today about what happens when minerals get high mineral content water, how it will affect even the greatest in high performance engines. What we have here is an advanced designed engine. This here is a V-6 turbocharged 450 horsepower original equipment engine. Now this engine was taken apart and presented at the Chicago and Detroit and other auto shows. So it's public knowledge, it's not a big deal. But there's some points in here that we're going to point out. Now the other engine that I have here is an LS Corvette type engine, which we're just going to use as an engine illustration. You can be able to get this presentation downloaded from SynMax University at synmaxperformancelubricants.com. Now, what you're going to notice inside of here is the mineral content within the engine block. So what do you mean, Clayton? Well, I'm not coming against the OE. It means the manufacturer. But what happened was the OE just put the water in. It seems that they never touched it, and if they did top it off, they just topped it off with the water that was of a very high mineral content. So they really didn't look after it that well. And I say, Clayton, that's 160,000 miles. That's got nothing to do with my race engine. Well, it can affect your race engine as well, because what we need to know is that even though this is running at 2 to 4 or 6,000 RPMs, the chemistry inside your race engine is multiplied at least 4 times. So I know this is a lot of miles, but it applies to your racing engine and street applications as well. What you would see in this picture, if it was closer, this was an overhead cam engine, as it would leak and then the high minerals would come out, it would actually, the water would get into the high minerals would actually eat past and through the gasket material. They would get into the engine, and then it would just leave dust and dirt particles everywhere. What was that? The evaporated water and the minerals. Say, what good does that do, Clayton? So what? Well, I'm going to show you why. You'll see here is the water pump. Okay, in this water pump, they did everything that they could to coat the pump, coat the casing, have a plastic impeller, but they had a steel shaft. That steel shaft was going to absorb all the metals. It was going to rust, and what was going to happen is that eventually that rust would destroy the seals, and it would hurt the rest of the water pump. What you would also see, which is the most important thing, is how the minerals would get into what I would call the exhaust side, okay? The exhaust side of the coolant passages of the cylinder. You say, Clayton, why is that so important? Well, in racing, we would always tune to the worst cylinder. That's usually the center ones, okay? They're running so hot, all right? So that is what we need to take care of, because I'm going to show you something in the end of this which is very important. So Clayton, how does that really work? Well, this wasn't the radiator, but we took something for a similar presentation, and this was an oil cooler from about a $600 radiator. It was used in racing. We cut it apart, and these people did not use a proper coolant treatment, but you can see how the minerals in the hot part went from hot to cold, hot to cold. Where it was hot is where the minerals got absorbed into the metal. Where it was cool, it wasn't. This is the part you have to take care of. Why? Because as it gets hot and cold, the metal starts to decay and destroy itself. And so you have to have that protected and have it as cool as possible. So even though this would happen in a radiator, this also would happen in the cylinders there, which also happens into your race and street motors as well. The key here, the hottest point that we're going to have on the engine is going to be the exhaust side of the pistons. Why? Because the heat dissipates from the left and the right, and it holds in the center. So we need to have really good chemistry to focus on this. Obviously, on this OE engine, which we saw, they didn't do that. They just put in water, and then they let the minerals go because, it was past warranty. But I'm going to show you something. On the intake side, if you were to see this illustration, it didn't absorb in as much. So it's like this was hotter and that was colder. It didn't absorb as much. Why? Because the intake side is cooler than the exhaust. You would also see here on the illustration that you would have the portions of the gasket material where the coolant would go through, that the minerals would actually embed into the gasket material. Now I say, Clayton, what's the big deal about that? Well, I'm going to show you something right now. Here's the bottom line, my friend. Okay? You would see in this illustration where the water leaked in the top edge and then it got into the center, like I said before. And then the minerals would stay as the water evaporated. Okay? But here's the deal. On this here, if you were to see on the illustration, if you were to get this, all right, the minerals actually on the center cylinder started to leak through, and you would see on the cylinder head that it leaked through the gasket, which meant the gasket started to leak. In all reality, that's probably where it was leaking and why they had to keep adding more water. All right? So you say, Clayton, what's that mean? Well, again, here's the coolant, the cooler side, the intake side, the less heat side did not absorb as much. And you'll see in the other illustrations that we have. The bottom line of everything is this. If they would have had a proper coolant system treatment with the right pH balanced water working with the coolant, with a product to actually coat this, to actually help transfer the heat, to actually take care of everything that had to work, then you wouldn't have had this result. All right? This could have been prevented. You might say, Clayton, is there a chemistry out there that's able to do that? Well, here at SynMax, we do have such a chemistry, okay? And you've seen it. It's the water cooler. So you could be able to take the water cooler premix, and it's got all the chemistries in it that you need. It'll lubricate the pump. It will take care of iron. It'll take care of aluminum. It will increase the heat transfer efficiency, which we'll get into another presentation. It will do a lot of things that you want it to do, okay? If they would have had this chemistry in there, chances are they wouldn't have had that gasket leak, and they wouldn't have had to put in more water, which put more minerals in, and really destroyed this literally $10,000 street engine. So, you might say, Clayton, but I already got my coolant in there. What do I do? Well, you could be able to get it in the concentrate form. It has all the chemistries in it, and you can be able to pour it in what you have there. Say, Clayton, you're pushing that really hard. Yes. Do you know why? Because I was one of those guys that had the head gasket go, just like you. The key here is this. If we can help the Achilles heel of the engine, the hotter parts of the engine, stay clean and transfer the heat so that the components can run better, in your race engine, what that's going to mean is all cylinders are going to operate at its most efficiency, which we're going to get into in the next presentation. So anyway, this is Clayton Balmas, and with SynMax University, I want to thank you for the time that we have, and please download that and check it out, and we'll see you at our next session. Bye now.